Dear all, welcome back to the next session of our HR interview series. So in today's question, we will be studying the question just beside you. So the question tells me that tell me about a challenging technical problem you faced in a project and how you solve it. So this is asking about just you faced a technical problem in any of the problem in anywhere and how you solve it. So whenever you are asked problems like this you faced in a technical problem or whatever the problem, whatever the question you are asked in each interview round, you have to keep one thing in mind, that this time you have to follow a method, and that is called star method. So whenever you answer, you reply to the interviewer, you have to reply following the situation, task, action, result method, otherwise they might reject you right then. So let's understand step by step strategically how we can implement this star method in this problem. So okay, this is the question. First analyze the question. Tell me about a challenging technical project you faced in a project and how you solve it. Okay, so first we will be following the situation task. So this is situation means what was the context when you faced this problem. So that is situation, the context. Task means what was the responsibility, what could you do. Actions means after you have faced this task, after you have actually faced these tasks, now what are the actions you took based on this condition. So the tasks and the actions you take, that is called actions, and this is the result, that after actions you took, what is the result, what is the outcome. So this is, so we'll be following this star method step by step strategically. Let's look. So this is how we will be answering the situation part. So we'll be answering like this in the interview. In one of my backend projects, I was developing a large inventory management system using Spring Boot, Prisma, PostgreSQL, and Next.js. As the system grew, several APIs were taking more than 8 to 10 seconds to load because they had to fetch complex relational data across multiple tables. Now notice here what we are doing. We are actually crafting the situation, we are narrating the situation, that as the system grew, several APIs were taking more than 8 to 10 seconds to load because they had to fetch complex relational data across multiple tables. So this is the first person where we are actually telling only about the situation, about the context. So why not, let's start again this situation part. In one of my backend projects, I was developing a large inventory management system utilizing Spring Boot, Prisma, PostgreSQL, and Next.js. As the system grew, several APIs were taking more than 8 to 10 seconds to load because they had to fetch complex relational data across multiple tables. So that was the situation. After situation, we'll be narrating the situation more in the second page also, such as inventory products, dispatch records, and financial transactions. This was negatively impacting the user experience. So the delay was negatively impacting the user experience. So that was the overall situation that occurred in that time. Now the tasks, what the responsibility we took in that situation. My responsibility was to identify the root cause of the slow response time. My responsibility was to identify the root cause of slow response times and improve API performance without affecting the data accuracy, and to improve the API performance without affecting data accuracy. The goal was to reduce response time and make the system scalable as the amount of data increase. So the goal was to reduce response time. The goal was to reduce response time and make the system scalable as the amount of data increased. So this was our task. So after the task, scalability was our task, reducing the time was optimizing the time was our task. So as per the task, what the actions did you took to fulfill the task. So let's look. First I analyzed the database queries. So at first we analyzed the database queries and API execution flow. I discovered several issues. So these are the issues I discovered several issues. Now we are narrating that what are the issues we have discovered. Multiple unnecessary database calls. So the first issue is that is multiple unnecessary database calls. Second, overfetching of relational data, that sometimes we have made multiple database calls that is not required from our backend system. Overfetching of relational data, I mean unnecessarily we have overfetched the data because of some wrong or dumb engineer. Now missing indexes. In some places, let's say we have missed the indexes on frequently queried columns, large payloads. In sometimes what we do, that we in the request try to extract a lot of, all the fields, instead of just we need whatever the fields. Let's say in some places you need only two fields like name. Let's say you need only two fields, name an ID of a person, because you want to display from the ID, from this ID you want to display this person, so you need to fill. So what some people do, that they provide, they try to face the entire payload. So these are the problems. Next person, so that was the action. To solve this, I optimized database queries. To solve this, I optimized database queries. Added pagination. Added pagination for larger data sets. Added pagination for larger data sets. Added indexes on commonly searched field. Added indexes on commonly searched field. Reduced unnecessary joins. Reduced unnecessary joins. Return only required fields. Return only required fields instead of complete objects. The things that I made you understand, that only required fields. If you need the name, then we will be returning only the name. So return only required field instead of complete object. Used proper details for API response. We have used to use proper details for API response. Tested query execution times before and after optimization. Tested query execution times before and after optimization. So these are the actions I initially took. That to solve this, I optimized the database queries, added pagination for larger datasets, added indexes on commonly searched fields, reduced unnecessary joins, returned only required fields instead of complete objects, used proper details for API responses, tested query execution times before and after optimization. My goal was to build an environment. Where collaboration feels safe, productive, and engineer focused rather than judgment driven. So we narrate like that, my goal would be to build an environment where collaboration feels safe, productive, and engineer focused rather than judgment driven. Result: the API response time improved from approximately 8 to 10 milliseconds to under 1 second for most requests. Now we tell the improve that previously what was 8 to 10 seconds, now that become 1 second. That means speed overall increased. So the API response time improved from approximately 8 to 10 seconds to under 1 second for most requests. The front end became significantly more responsive, database load decreased, and the solution allowed the application to handle larger data sets more efficiently. Additionally, the optimization techniques were adopted in other modules of the system. So now we narrate about the front-end system also, that the front-end becomes significantly more responsive, database load decreased, and the solution allowed the application to handle larger data sets more efficiently. Additionally, the optimization technique were adopted in other modules of the system. So this is how we can narrate the entire situation. So after the context has been done, interviewer can ask you those questions, that how did you identify the bottleneck? He can ask you that what you informed, how did you identify the bottleneck? So you can answer like this: I analyzed API execution time, reviewed SQL queries, checked query plans, and measured database response times to locate the slow operations. I analyzed API execution time, reviewed SQL queries, checked every plans, and measured database response time to locate the slow operations. So this is all about researching of API execution time, deep diving and debugging of SQL queries, checking query plan. Now second question, recruiter can ask you that what indexes did you add? So you will be answering like this: indexes were added on frequently filtered columns such as product IDs, inventory IDs, startup fields, and created timestamps that were used in sorting and searching. So indexes were added on frequently filtered columns. What indexes did you add? So they can ask me that what indexes did you add to improve the system, to improve the database load? So we added on frequently filtered columns such as product IDs, inventory IDs, startup field, and created timestamps that were used in sorting and searching. How do indexes improve performance? Indexes reduce the amount of data the database must scan by providing a faster lookup structure, which significantly decreases query execution time for search and filter operations. So indexes reduce the amount of data the database must scan by providing a faster lookup structure. So indexes actually reduce the amount of database that must be scanned to provide a faster lookup structure, which significantly decrease query execution time for search and filter operation. Now the question 4 that can ask me, what trade-off do indexes have? So the constraint: indexes improve read performance but increases storage usage. So this is the drawback, that indexes improve read performance but increases storage usage. So it increases storage usage also, and can slightly slow down insert, update, delete operation, because the index must also be maintained. So as we have to maintain the index, insert, update, delete, the operation can be a little bit slower. So this is how we answer this question step by step. We are utilizing the STAR method: situation, task, action, and result. If you want, we can again recap. Let's recap again. Okay, so in this time I'll be listening you like entire interview round. I'll just as I should tell. So like this, in one of my backend projects, I was developing a large inventory management system using Spring Boot, Prisma, PostgreSQL, Nextjs. As the system grew, several APIs were taking more than 8 to 10 seconds to load because they had to fetch complex relational data across multiple tables. So this was the situation. Such as inventory products, dispatch records, and financial transaction. This was negatively impacting the user experience. My responsibility was to identify the root cause and of the slow response times and improve API performance without affecting data accuracy. The goal was to reduce the response times and make the system scalable as the amount of data increased. My responsibility was to identify the root cause of the slow response times. My task was to identify the root cause of the slow response time and improve API performance without affecting data accuracy. The goal was to reduce the response times and make the system scalable as the amount of data increased. After the task, now we move to the action portion. First, I analyzed the database queries and API execution flow. I discovered several issues. I discovered several issues like multiple unnecessary database calls, overfetching of relational data, missing indexes on frequently queried columns, large payloads being returned on the front end. So I discovered several issues that were multiple unnecessary database calls, overfetching of relational data, missing indexes on frequently queried columns, large payloads being returned to the front end. To solve this, I optimized database queries, added pagination for large dataset, added indexes on commonly searched fields, reduced unnecessary joins, reduced only required fields instead of complete object, utilized proper DTOs for API response, tested query execution times before and after optimization. My goal would be to build an environment where collaboration feels safe, productive, and engineer focused rather than judgment driven. The API response time improved approximately 8 to 10 seconds to under 1 second for most requesters. The front end becomes significantly more responsive, database load decreases, and the solution allowed the application to handle larger datasets more efficiently. Additionally, the optimization techniques were adopted in other modules of the system. So this was the result of the problem that I solved utilizing the SQL optimization tricks, and this is how I tackle the complex situations. So okay, I make you understand the question, how you should reply, and at the end I also showed you completely entirely that how you should also tell. So we are meeting in the next session.